confirm that my audio is perfect.
Yes, sir, it's perfect.
Oh, good. Yeah, so to everyone who is currently on this call, good evening. And good evening also to those who will join. Yeah, I think we can translate the time to for those who are joining from other zones, right, in the global geographical system. Yeah, the time can also be translated wherever they've joined. So I think today's class also is very key. What we are doing right now is that we are laying the foundation, the fundamental, because the fundamentals really is what matters. Yeah. If we miss the fundamentals, we'll find it very difficult for us to be able to justify a lot of things. And yeah, working across the industry and doing petroleum engineering is all about laying physics-based justifications, right? Having reasons for why something was done in a particular way, or ensuring that, yeah, you don't make mistake, especially with the fundamentals. You don't make any error because people expect um, you to know the fundamentals. Yeah, they expect that you should know the fundamentals because once you know that fundamentals, it gives them confidence that they can be able to build on others, on other things. You can be able to build on it once that fundamental is well grasped and well known. So what we are going to be doing this evening is basically to revisit one of the key fundamentals, all right, in petroleum engineering, and that has to do with basis of the basics of pressure. So we'll be looking at pressure. We're looking at pressure, and if we recall in the previous class, I have made attempts to discuss with us about the basis of depth, all right, and why we should be very aware of the nature of depth that we are using. Okay, so I will just do a quick recap by stating clearly that for those of us who are quick to go pick up any software and start working with the software, you are going to definitely encounter depth. All right, you will encounter depth. Whether you're working with TechLog, you encounter depth because variably all the log sets that you're going to be working with, inherently they have depth attached to it. And you will not just be working with a single depth if it is TechLog. Basically, the depth that is attached to them is the MD, but you're going to also be able to get the derived logs out of it, which is the TVDSS. All right, because that's basically where you're going to be tying other things to. So that's the one that you're going to be using for your analysis. And that's the one you're going to also be giving to other engineers that you're going to be working with. Or whether you're working with Prosper, the petroleum expert Prosper, you're going to encounter depth because you'll be dealing with maybe downhole equipment. When you come across the downhole equipment section, you will see depth. You have to enter the depth of accessories or components that you have in your well. So you need to be aware of what depths you are entering. So you need to also be aware to know which data you'll be using. And then what if you come across a schematic or a well status diagram? That well status diagram, the depth on it does not have the depth that you should be entering. What do you do? So it's critical that, yeah, we know the depths that we are dealing with. And similarly too, yeah, for those of us, whether you're dealing with geology and you're going to be working, or you're dealing with the material balance, you're doing analytical material balance modeling, and you're going to be working with, you need to be very, very, very with. Take for example, where basically your pressure versus depth, or your pore volume versus depth. All right. a data that a geologist would have given to you, So you need to be sure what data that you're dealing with, what depth they have given to you. Ask the necessary question. So this evening, without any further ado, I think we'll go straight into that of pressure. That of pressure will not keep us long, because I think the fundamentals have been laid. And we've stated it clearly that when you're dealing with pressure, you should not be using the measured depth, except if that well is a fully straight or vertical well. And then you don't have the deviation survey. You don't have the deviation survey, because we've seen cases where some wells that were, or some assets that were maybe inherited from previous operators, there's no deviation survey for the wells. There's no deviation survey. So when you are met with such kind of situation, you need to discuss with the operator. If they've not run a gyro, as we discussed earlier, they need to give you like a kind of a basis to continue with what we call with an assumption to use a straight hole. So when you're using the assumption of a straight hole, it means that you're assuming that the MT and the TVD and they are equal. Okay, but that is not something that you just pick, because it has a lot of implication. But you need to state it clearly that for them to be able to minimize uncertainty or mitigate uncertainties that might arise, that are surrounding basically the depth issue, that they need to go and acquire that gyro. That gyro is critical. It's critical. But the project cannot stop or be kept pending, waiting for gyro service to be run. And then we said also that if you are making calculations that have to do with friction, of course, if you have your deviation survey and you've entered possibly your downhole equipment, then the computer itself knows that it will be using the MD. Okay, it knows it will be using the along hole, the path. That's what friction is all about. However, what if you have to do the computation on an Excel spreadsheet? Because it's not every time that we depend on software that already has the underlying physics coded. What if you have to do a calculation? What if you're working on a research paper, or basically you have to do like kind of a calculation to vet or verify that the pressure that you have, or what the system is giving to you, the software has given to you, is correct. Or you find yourself in a system where someone has already written a macro in an Excel, and that's what people work with, and you also have to use that macro. It's essential that you are able to ask certain questions if you cannot see the code and see the questions that the person have written. If you cannot see it, you need to ask questions and find out, okay, here I'm supposed to be entering depth. Hope we are clear that for this particular analysis that has to do with this is the depth I'll be entering. Or you go ahead. Now that you know there is friction, you know the depth that you'll be entering is the length, is a long hole. That's what you'll be using. But when it has to do with pressure, please, let's be clear on one thing, that we'll be entering the TVDSS. Okay, so I'll share my screen, and please, if you can see my screen, just give me a thumbs up and that'll be good. Okay, yeah. All right, so if you can see my screen, I think we can continue at this point. And first of all, I want to also congratulate who have done very well in the quiz. Congratulations. I think that means the fundamental of depth, which is the starting point, I think is good. I'm really impressed. I'm glad to know that that we have basically picked up that aspect. So the agenda for today, I mean, I will not follow this agenda religiously because I'll try as much as possible to ensure that, yeah, what I'm going to be sharing with you comes out as clear as possible. Okay. And then, if not in this class, I'll also find a suitable case studies for a particular case study that we can work with, especially in Excel. I mean, the week leading up to today has been quite a very busy one for me. And I just hope that, yeah, we'll be able to find maybe a window of 30 minutes, even outside our regular schedule, to be able to come and run that particular class that has to do with the case study where we use Excel, because I would like us to be able to do some form of BHP interpretation. And then when we do that BHP interpretation, which is bottom hole pressure interpretation from the data, from the raw data that have been obtained, we are able to use it to know where our fluid contacts are. All right, what fluid we are actually dealing with. Yeah, and where basically we have equilibrium in terms of either a gas oil contact, oil water contact, or gas water contact. Yeah, I think we'll definitely find that window. I will inform the coordinators to see how we find a suitable window of 30 minutes. So I'll be able to have that section. All right, so let's hit the road running. Okay, so yeah, in petroleum engineering, of course, you're going to be dealing with pressure. You can't run away from it. You're going to be, of course, we all have written in our CV at some point, or we have told HR at some point, or we have it somewhere in our minds that that we can work under pressure. Okay, whether we have said it implicitly or explicitly, expressed it explicitly, it's just there. And most organizations that will tell you that, look, they do work-life balance. Yeah, it could just be a mirage. So what they expect you to do is to be able to strike not a balance, but basically to find a rhythm within the pressure. Yeah, within the pressure regime that you're going to be faced. You just find a rhythm. That means that you're able to find a time when to rest and a time when to be active. Okay, so don't be scared. I mean, pressure is what you know. Okay, it's not far from what we have already learned in physics, which everyone in this community has done very fantastically, and we are here. So pressure is what you know. But in petroleum engineering, we are going to be dealing with pressure that exists within the pores of the reservoir. Okay, and also we are going to be dealing with pressure that exists across our tubular, whether the vertical section or the length of our tubular leading up to surface, and the pressure that also will take the fluid from the wellhead down to possibly the manifold, and even beyond the manifold to the separator, and beyond the separator definitely to the sales point, because it's incomplete until it gets to sales point, because that's basically where you make money, where we make money. And every E&P companies, they have two objectives. One, they are looking at optimizing production, and next they are looking at optimizing cash flow. Now, even when we say optimize, we know that optimize for them is basically maximization. Yeah, so I'll rephrase that to say that for E&P company, they are looking at maximizing production and maximizing cash flow. Yeah, so those are critical. And when we say maximizing production in this sense, they are looking at maximizing oil, gas, or condensate. If the focus for them is oil, and they have a scenario of gas, then also they want to maximize the condensate. All right, but let's note that, yeah, with the drive of NUPROC right now, even gas is critical. Penalties have risen from what it used to be, $2 per thousand SCOF, if production is above 10,000 barrels per day, to what we have now, which is $3.5 per thousand SCOF of gas. So they are doing all of this to discourage companies from flaring gas. And almost, and even at all flaring sites now, they have awarded it to companies to be able to build either a small scale LNG or to serve as an off-taker to be able to pick up the gas that is meant to be flared. And these are fantastic activities. These are things that really gives me joy that our industry is dynamic and is growing, and our regulators are doing an excellent job. Yeah, because I mean, for the FDPs, when you're working on feasibility studies leading to either a feasibility plan or what we call the feasibility, the field development plan, FDP. All right. In other climes, let me use an example like Malaysia. They don't permit flaring. They have a zero flare tolerance. All right. So the gas that you're producing has to either become a sales gas or a used gas. So you are either using it within your facility, either for power generation, or you're using it, re-injecting it for either pressure maintenance, or you're using it to basically lift oil in a kind of cycle, because the same gas used in lifting the oil, you are going to basically take it to the separator, recover the gas, and bring it back again and reuse it, or you monetize the gas, so which is the sales. So you need to monetize it. You need to be able to look for a gas sales agreement and basically pass it to someone else. You need to pass that gas, do a custody transfer, give it to someone, all right, and get paid for it. So flaring is not tolerated, but yeah, we are still working towards such scenario. There used to be a time when there was no penalty to flare, and then little penalty came, and then it rose. Started seeing it within economies. We are doing economies who have to put in $2, and even that $2 companies were still happy to pay it. All right, they're happy to pay it. But now 3.5, that's going to erode a lot of value, financial value. Okay, so pressure is basically what we know, and this pressure exists within the pores of our rock, of our reservoirs, and this is a cartoon of what the reservoir looks like. The 5 steps leading to heaven is a clear picture, but let's just work with what we have here. It's something that we already know. Okay, so that fluid that has been generated from the source and has migrated, all right, through cracks, all right, and has got accumulated because of how the structure is. Because if the structure is not convoluted like this in such an anticlinal manner, definitely it would have started flowing sideways and looking for any means of seeping to surface. But this has basically given us what we call accumulation, and this accumulation definitely because of certain features which has to do with the faults and the seal. Yeah. So when we talk of pressure, and pressure plays critical roles for us. We need pressure because definitely it's pressure gradient that enables the fluid to flow. All right, it's the variation in pressure that makes that flow possible. And also, of course, when we have that accumulation occur, okay, it enables also for us to be able to build sufficient pressure. And this pressure is needed because at the end of the day, we are going to connect a tubing, a straw to this reservoir. And that straw that has been connected to the reservoir, we need pressure to be able to pull or move the fluid from the reservoir, which is the work of engineers, you all, to ensure that, yeah, we're able to do the right, we have to get the right tubing, we have to ensure that everything is okay, to see that this fluid, we are able to move it, okay, in that economic manner, with the natural pressure up the tubing to surface, except where the need is that we need to install other support systems like pump utilize the gas. Yeah, that's when it. But everything we've discussed so far, we'll find it within this picture. Yeah, this gives us like a detailed picture of what we are dealing with. Okay, but I'm not going to discuss the details because there will be another class. Yeah, another meeting we are going to have that we go into the details of this. But that is just to give us an idea. Remember, we've talked about the IPS, which is the integrated production system. So this is like a snapshot, yeah, of the IPS. And then when we look at this IPS, we see that right from the reservoir, all right, we're dealing with pressure points all the way to the wellhead. So from the reservoir into the wellbore, from the wellbore to the wellhead, from the wellhead to our separator, from our separator, which is a two-phase here, gas and liquid, down to stock tank. All right. And then of course we carry out the custody transfer, which is also the gas. You are monetizing it because it's going to sales. Yeah, I think this is very fantastic. We're not going to flare it. So we need to maximize cash flow. So we see that for every section of our system, we are definitely dealing with the pressure. Yeah, we are dealing with pressure. That is the reason why things are moving. That's the reason why our fluid is flowing. And when our fluid stops flowing, yes, we need to look at it again. It's as a result of pressure. All right. Either there has been a decline in pressure, the pressure that we have maybe is not strong enough, and then we need to be able to look for something to supplement it, a support to be able to support it. So it could be a support that is happening along the tubing within the well, or it could be a support that is happening along this line. Okay, so it is along this line. It could be a support that we want to use to be able to move these fluids. So maybe we have turbines, we have maybe we have pumps, we have turbines to be able to move it. And then of course, when we have scrub and we have our gas, maybe we want to connect compressors that will be able to compress and be able to push it even further. Yeah, same thing also even along this line as well. We want to be able to have sufficient pressure. Okay, so if we have the turbines could be able to support us and push this pressure all the way to the tank. The tank. So let me run through this slide that we have, and then we can take questions. Okay, so when dealing with pressure in the industry, also you need to be careful, just like we said concerning depth. All right, I think let me just lay this as a principle that when dealing with pressure, just like depth, recall when we talked about depth, we said depth comes with certain attributes. When you're dealing with depth, the value, you don't want to give the value alone, you also want to give the units, but you don't want to give the value and the units alone. You also want to be able to talk about the okay, yeah, sorry about that. Okay, but I guess we are enjoying the class, so let's move on. So yeah, so you also don't want to give only the value, the units, and the path. So we all know what the attribute of depth is. How about pressure? Pressure also have attributes. So when you're dealing with pressure, please, I want to state this categorically. It's not in the slide, but I need us to be aware of it. We need to provide the value. The value is a number. Is a pressure 2000? Is a pressure 1000? Is a pressure 300? Is a pressure 400? Is a pressure 8000? Yeah, we need to bring that value, but not the value alone. We also need the units. All right, both are critical, but not those two alone. Now, with third attribute we need to bring is date. We need to be able to bring date as well. Now, the reason why do we need date? We need date especially if we're dealing with pressure that has to do with reservoir. Okay, because of course in our field, for those of you that will be very much involved in reservoir engineering, yeah, you will have to supply pressure, right, to other team members. The reservoir pressure, you have to be dealing with the pressure of the reservoir, how it's evolving, how it's changing over time, and how it's going to impact on your recovery, all right, in terms of the maximization of that production. Team with the initial pressure, of course, that will not work. Okay, such a model will not work because there have been withdrawal, there have been depletion. Okay, things have happened. So we all know the equation in material balance that relates all of that, and definitely it means that pressure have changed. So for that volume that was withdrawn from the reservoir, what impact did it have vis-a-vis the dynamics of the system in terms of the drive? What influence does it have? So it basically means that we need to be aware of those three properties: the unit, the value, the unit, and the date. Yeah, we need to be aware of that, and we need to provide them anytime we are providing pressure. We need to be able to provide it even when we are dealing with pressure along line, because of course we are going to be reading pressures along this line. We are going to be reading pressure such as the wellhead pressure, or what we can call also the tubing head pressure. You need to provide the date because it changes. It's not going to remain the same. So as you are supplying that pressure, you need to tell the person that this is the pressure as at this XYZ date to ask question, because even the person that you're asking does not know whether it's a G or whether it's an A. Yeah, so you should be able to just work with it. And as you work with it also, you can do like a quick check. I think I'll leave this with you guys. Find out what is the impact, okay, of maybe the 14.7, because that's basically the difference. So why at PSIG, which is the gauge pressure, all right, it is exclusive of 14.7. It's exclusive of 14.7. The PSIA is inclusive of 14.7. Okay, that brings it to atmospheric. Okay, so you see that gauge pressure is this, and then in atmospheric, you see the length. You see, it's a bit longer, it's bigger, all right, by this addendum 14.7. So I'll need us to basically maybe you want to be able to pick up an equation, maybe an equation that has to do with either rate calculation or an equation that has to do with friction calculation in petroleum engineering. So it could be a Darcy equation. Okay, I want to calculate rates. And then if I want to calculate rates, I want to keep all terms constant. And then I want to vary the pressure, especially within the withdrawal, the drawdown term. I want to be able to say, okay, at this point, I'm using G. And then I come back again and I say, okay, that's G that I'm using. What if it becomes PSIA? What would be the influence like? I mean, sometimes some people will be like, it doesn't have any influence, but I need you to try it out and let's know in our next class. Or you can pick up something, any of the equation that has to do with maybe friction calculation, one that is very simple. Yeah, one that is very simple, not one that requires the Newton-Raphson that only a computer can be able to solve. Okay. Yeah, you want to pick up that, or if you can be able to code it, to pick up any of the equations, maybe the Haaland, the Darcy-Weisberg, the Churchill, and so on and so forth, to pick up one of those equations and you see what it could actually be like. Yeah, I think that would be fantastic. Let's get an idea. Does it have any influence? Does it have any impact? If it doesn't, then we can be able to share that in the next class. I think, yeah, it's not everything that I need to be able to that I will be able to share, but when we have done that research, when we have come up with that understanding, we can be able to talk about it. So yeah, so so when we're dealing with pressure, especially subterranean pressure, definitely we are going to be encountering particularly a pressure that we call the formation pressure, okay, which basically has to do with the pressure that exists within the pore pressure that exists within the pore. All right, and that pressure is what gives rise to the fluid pressure. So as we are dealing with it, our subterranean condition does not only have, it has pores because there are rock matrices, okay, that have been arranged by nature, all right, in such a way that while they are arranged in that way, they have given us certain pores that can be able to retain fluid. So also those rock matrices, or what we can call grain, they are also going to provide their own pressure. And that entire lot gives rise to what we call the overboarding. Yeah, the overboarding and pressure. So this is just basically a cartoon that gives us like an idea of what we are dealing with. All right. So this is a pressure transverse plot. If everything is as clean as possible or good, that's how we should be looking at it. But what it has basically, what this is telling us is that based on this equation, definitely you will find that the dependent property is overboarding. These are the independent property, if I'll put it that way. And then also from what we know in little mathematics, you cannot have your fluid pressure higher than your overboarding. All right. Neither can you have your grain pressure higher than your overboarding. Yeah. So if I'll put it that way, I think that's the way to look at it first of all. So what that basically will mean also is that you will see that your overboarding line will be way on the right compared to that of your pore or your fluid and pressure. Yeah, compared to that, you see it will be on the left, and then you can be able to find the difference. Yeah, you can be able to find the difference. But it's good and clear that, as I mentioned, you cannot have it cross the overboarding. Please take note so that in case you come across any system where maybe the fluid pressure, or you are discussing with someone and the person is telling you about a fluid pressure that is higher than the overboarding, you need to be able to ask certain questions. You need to be able to know what this equation looks like. Yeah, you should be able to know what this equation looks like. That in this equation, we are not dealing with a ratio on the right. All right. And then the grain pressure is not basically less than 1, because if we're dealing with a ratio and the grain pressure is less than 1, then someone can be able to say, okay, maybe when we multiply it with overboarding, that's when it will be lower than FP. But no, when you look at this, you'll be able to tell that, of course, overboarding will always be higher. And then all things being equal, you're working against a benchmark. That benchmark that you're going to be dealing with is a benchmark of hydrostatic, okay, which is what you call the hydrostatic pressure. So the hydrostatic, as the name implies, is fluid. It's fluid. So we are dealing with fluid. So we have fluid filling up the pores, and of course, we have to deal with fluid that has to do with water. We can use that as a first pass, all right, in our analysis. I think there are a couple of slides that will address that. So also we are going to deal with, also come across systems that are not going to follow specifically maybe a very good and benign kind of arrangement that is clean. We are going to come across systems where, of course, we'll be dealing with pressures that don't follow the hydrostatic pattern, okay, or the hydrostatic model. And then for those kind of systems, they are either called, we call them an abnormal. So basically they're abnormal. And when they are abnormal, they can either be an overpressure system or under pressure system. All right. Yeah, it can either be overpressure or under pressure. Now for some text has gone on to call the under pressure subnormal. Yeah, but what is not normal is not normal, whether it's on the high side or whether it's on the low side. Yeah. So we are dealing with either over means that it has gone beyond the hydrostatic, and under pressure means that it has gone below the hydrostatic. Yeah, so we can be dealing with that. And of course, we need to be able to be aware of this clearly because of the critical importance. note, whatever we are dealing with, especially if you recall, most of what we discussed here, we are efficiently and well related more to the reservoir and the PT, and even necessary for the process engineers who are going to be modeling the surface facility end. All right, very necessary to them. But what we are discussing here now will be also even more relevant to the reservoir engineer and also to the drilling team, to the drilling engineer. So we want to be aware of this, because if we are not, then we will run into trouble when we are drilling our well. We'll definitely run into trouble when doing that. We'll also not be able to determine what our reservoir production strategies will be, especially even the pressure of the reservoirs. Will definitely be wrong about it, because we don't even understand whether it's within the normal regime or whether it's actually outside the normal regime. Okay, so when we are looking at the different fluids, okay, when we are looking at different fluids, this gives us a clear picture of what we are dealing with. Okay, so I think for the other class that I'm asking for, I'll not go into these equations that are here, but this is what I want to pin at the back of our mind, that what is here is typical. So please, let's take note of this word here, typical. Okay, but most things in petroleum engineering, as we said in this community, trying to give us clue of how to find our way through petroleum engineering. We don't deal with fixed numbers. We mostly deal with the range. All right. Most of the things we are talking about in petroleum engineering practice, they are range. Nothing is fixed. The reason, of course, I think I've mentioned in one of the class, nobody has gone into the well. Nobody has gone to the subsurface. Nobody has gone to the end of the tubing. Nobody has gone to the reservoir. Yeah, no one has done that. And even those that have delivered to us, the tubulars that we are working with have set high safety margin over whatever they are dealing with. So it also means that even we that are going to be working with other things, that we flow through those pipes, we are also going to be dealing with range. So when you see these numbers, please be clear that what we have set here is typical. So the fluid gradient that is typical for water is what we are defining, or what we are showing here, that it will fall somewhere within this range, within this point. So you see it somewhere within the that of hydrostatic for fresh water, but it will be higher than 0.433, and then it will tend upwards. And then when we are dealing with oil, all right, sometimes we'll find maybe 0.3 and above, but it will not cross 0.4. It won't cross that. And then we are going to be dealing with gas, and gas, of course, we are going to see it. We are going to find it very much and within the lower 10. So that means generally what we're going to be looking at is that we might find ourselves, if we are dealing with the pressure transverse here, on the x-axis being pressure. Remember, you're going to be dealing with this kind of graph in petroleum engineering a lot. So this is our depth, and this is our pressure. This is our pressure. So you'll find this in a lot of areas in drilling. For those that are doing drilling, remember we have talked about it here. So in drilling, what you will find is that maybe you are working with an envelope that has to do with your fracture pressure, and maybe an envelope that is very benign that has to do with your pore pressure. Okay, so you have your FP here, your fracture pressure, and then you have your pore pressure. Yeah, and then of course, if you are dealing with good. Okay, so if you are also dealing with reservoir engineering, okay, let me say if you're in the PTEC range, you will deal with a pressure gradient or transverse gradient plot that has to do with a plot that we know that generates the VLP that looks like a hockey. All right. what generates this hockey is basically a set of points that have been put together carefully, that at the initial onset, somewhere around where we call the wellbore, the top of F, we have basically picked a PWF that moved backward and later find itself moving forward. So if this is 0, if this is 1, if this is 2, if this is 3, all right, we find 4 coming to this point, we find 5 coming to this point, we find 6. So it's now moving back, okay? So that when we plot it, we can be able to see the structure. So this is our 0, and then we see it moving down. In terms, remember that this plot is a plot of pressure against rate, okay? So you see the pressure coming down. So the pressure moved back and then it started moving forward. So I will discuss this in details when we are talking about, because this is the energy balance equation, and then it started moving them forward. Yeah, but the case study that we're going to be dealing with is basically a case study that has to do with fluids contact and prediction. And in such a case study, maybe we are dealing with we are going to put like specific trend line. So let's say we have clean data that basically looks like this. Let me put it this way. And then definitely when we take a gradient through this point, or a trend through this point, we see it going this way. And then if we take a trend through this other point, we also see it going this way. Okay, we see it going this way, which means that there's an equation for this point, a slope for it, and also there's an equation for this point, a slope for it. All right, and this is where they intersect, and where they intersect is where we can now assume to be our contact, because that is where the equilibrium exists. Remember, this plot is a plot of pressure and depth. All right, it's a plot of pressure and depth. Yeah, so I think basically giving us the pointers as to what we are dealing with there. So I won't go into the details of this, because this is also just to give us an idea of what we are dealing with. I see that we have just a minute before we hit 8 o'clock, and I would like to stop at 8 on the dot. So here also, this gives us a pointer of what we have been discussing in terms of the plots. And then we can see that for A, we are dealing with pore pressure that has to do with gradients for oil. For B, we are dealing with pore pressure that has to do with gradients within water, not necessarily hitting that of water yet. Yeah, and then here we know that now we are dealing with saline water. Okay, but we don't have anyone that is within that of gas, and of course this can be typical as well, so that if you see your pressure, that you acquire downhole pressure just going straight this way, and you put a gradient through it, or you've done the calculation, you should be able to know that, okay, what I have is gas. What I have is gas, but this gas has gone down to what we call the gas down to. So what we have is a GDT scenario. All right. So this well that we took these pressures from, we did not see a clear contact, because what we have here is a gas down to. So it means that we did not see any other equilibrium, any other fluid equilibrium basically existing. Okay, so let me reiterate the message for today's class. The message is this, just like we had on the depth. The message is that we are dealing with 3 attributes. All right, 3 attributes. So I don't know, someone in the meeting, can you help us? Yeah, call the attributes that we are dealing with. What's the first one? We are doing a recap so that we can be able to tie in the message. It's like picking up the fragments. All right. So someone that has been in the meeting from the start, or that heard what we mentioned about the attributes, as an engineer, when you are handing depth over to someone, what should be the qualities of the depth that you're handing over to in terms of the data, or you are receiving from someone. What question should you be asking? Okay, so there's someone on the call that made a very fantastic introduction of himself. Yeah, I want to thank him. I think this is the way to go. Okay, now I know the person better. The person is a final year student of civil engineering. Abba, are you still on the call? Abba Mohammed, hello. Hi, what's happening? What if there's a prize to be won? What's happening?
Please, guys,
We
let's
talked about
contribute. As is, we have some of Franklin here was here. We have Franklin and the Mona Gottman. At least they were here from the beginning. So those
That's
contribute.
what's happening. Because that's the key message. Yeah, and we are just trying to tie up the fragments of what we have discussed so far. And if we miss this part, then I think definitely we have missed a lot, because even in the case study I mentioned that we are going to be dealing with the next time we meet, or if we find the 30 minutes window to come in and discuss, which shouldn't take us more than 15 minutes, and then we'll give room of 15 minutes for question and answer. That case study, yeah, we'll be meeting the same message. Yeah, that message will be there because we'll find it. But I can't see anyone making an attempt. On the chat, someone has tried. That is Enimona, said the date as one of the attributes. So what I will do is that I will put 3 bars, and then I'll come here and I'll put date. Yeah, because date will not be the first thing that we're giving out. Good. So what else again? Okay. Yeah, Enimona said the value. So Enimona, where does value fall? Is it the first, the second? You want to be able to arrange it properly. Okay, so Franklin Obika said the unit second.
The second.
Perfect. So yeah, so we are going to drop the unit here. That's correct. And then that leaves us with 1. So without waiting for any other person to mention it, I think Enimona has already stated the value. All right, so we need a value. So the value here can be 3,601. And then we need the units, which definitely you can say, okay, we are dealing with PSIA. And then we need the date. So the date of this pressure, we can say it is the 12th of August, 1992. Good. So if someone is building a model, someone asks for this pressure and you give the person 3,601 PSIA, that is the reservoir pressure. Then the person is building the pressure currently. It basically means that that person will need to either ask you to, can you go and run a prediction? All right. Yeah, because possibly we don't have the current pressure. So the person will say, okay, if that reservoir has been producing since 1992 till date, till 2024, let's say till 2024, can you be able to go back to your model, which is the reservoir model, run prediction, and tell me what influence would have our withdrawal, what influence will it have on this pressure, and what is the current pressure that I'll be using in my model? All right, what pressure will I be using in my model? Or I can tell you that, okay, I need the pressure as at 2003, or I need the pressure at a particular date. You should be able to run that. And let me just state it, you can be able to also do that back of the envelope calculation on this. Okay, you can be able to do it, because I'll just give one instance. So for example, if I know that this particular field started producing in 1984 and 84 to 1992, okay, it gave us, let's assume, 1.2 million STB. That is in terms of cumulative volume that we withdrew, in terms of cumulative volume. So if I have the production profile in terms of, if I have the production profile in terms of, let's say oil rate, and I have another buyer that talks about my cumulative. I wish I can be able to write, that talks about my cumulative oil. Okay, cumulative oil. And then of course, cumulative oil that we know that it cannot go downward, it keeps going upward or it stays flat. So if my rate has basically been like this, okay, has basically followed this path. So let's assume there was a pause, a shorting somewhere here, and then it comes back again, or it comes back even at a higher rate. So let's say I have this small one here, and then I have a higher rate, something like this. Yeah, then it means that my cumulative also would have been increasing, although it will have a steeper increment here. To have a steeper increment. I think I just try to ensure that I bring in a lot of message for you guys so that you can go with a lot of things. So it will have a steeper, because you see the cumulative rate at this point here will be higher. So it will be steeper here, and somewhere here it will start becoming gentle. But when it hits this point, it's going to stay, okay, and then it will remain flat during the period of shorting. It will remain flat. It will not increase. Why is my hand going upward? Yeah, and then we are going to have back that increase, something like this. Okay. So if I know the withdrawal, if I can be able to have an idea of what the cumulative has been, all right, fragmented cumulative within this timeline. Okay, let's say within 94 to 1990, I know what the cumulative is. Within 1990 to 1992, I know what the cumulative, and I know what the cumulative and the pressure is. I can be able to also do all of that. I can be able to do all of that. Yeah, I can be able to do all of that across all sections. Okay, and then use that basically to predict that, okay, so what volume have I withdrawn? Right, across this entire period, what volume? I can even take it to the maximum. Now, if the smaller you do it, the better your result. Or you can just take the entire ballpark if you don't have the time. So what volume have I withdrawn, and what is the ratio of that cumulative volume to the pressure? So yeah, you're going to have like an idea. With that range, you're going to have an idea of what cumulative is. That, okay, every time we withdraw this value, this is the pressure that we find. And then from that pressure that we have withdrawn and that cumulative, we'll now say, okay, how many volume cumulatively did I withdraw from the last time that we have pressure to this current time when I need pressure? And then you are going to now use that particular value that you have to multiply the ratio that you have, and it's going to give you like a pressure, an idea of what the pressure would be. And then that gives us basically a sense. Is it accurate? No, it's not accurate, because there are other dynamics that would have taken place. We did not consider that there could have been change in the drive mechanism over time. Different response would have taken place and all of that. So definitely it will not be accurate, but just because an idea. And when you don't have pressure, you can be able to stand on that. It's on that basis that I created, or I synthesize. Yeah, that was the right term. That I synthesize pressure that I've used in my model, and I've stated it clearly in my recommendation that acquiring pressure moving forward, especially at the point of intervention, we need to be able to put in our program that we need to acquire PHP pressure, because that is going to improve the model that we have, all right, that supports the program. Yeah, you need to be able to state that as well. But thank you so much for those that have responded. I think, yeah, it's very fantastic. This is the key message of what we are dealing with. This is the key message, okay, of what we are dealing with. The key message today is what we have within this green box. If you are just joining here, that if you are dealing with pressure, you need a value, you need the units, and you need the date. You need the date. Now, this is mostly applicable, especially when you are dealing with pressure within this, especially pressure that has to do with this. Okay, but if you are dealing with the one that I mentioned, that if you are working with them, for those of okay, I drew it when I was dealing with this. So if you have this as, let's say, your pore pressure and your fracture pressure, okay, so in that instant, that is drilling. That was 10. That was drilling. So you may want to retain this same window. Yeah, you want to retain this window and work with this window. Okay, but if you are dealing with any other pressure that has to support production, not drilling, production, then definitely the pressure that you're going to be dealing with, you want to supply these three variables to whoever that you're discussing with. Thank you so much, everyone. Thank you, guys. I think